So let's begin with handling user input and validation. So we need to ask the user to enter this value and this value, which is supposed to be an unsigned byte. So it's the byte in range from 0 to 255. So let's start with prompt. Let's just perhaps get rid of this code, because we can start with blank line. And so let's just say that we want to display our first prompt, which is input first 8-bit. Okay, so we'll just do it like this. So once they make input, we can say input, and our input buffer is going to be just this buffer. Okay, so we're going to specify the buffer, and the second argument, of course, is the length of this buffer. Okay, so this is user will see this prompt, and then the user will be inputting this. We can interpret the input in this buffer as presumably a 32-bit value. So we have this macro A to D ASCII input to double word, and we're just going to use it to make a conversion, right? So we're just going to use this sample to adopt it in our code. And here I'll just add a comment that take user input as 32-bit int and convert it to EAX, right? So we have EAX will contain the result. Now, of course, we need to be able to check for overflow. So definitely we need this type of logic. So if there is no overflow, we can copy and paste this line and say, okay, so if there is no overflow, we can jump forward. Okay, so this means that here, if I align this comment with what I have, so if overflow flag is not set, this means that everything is okay. Or we can just clarify it, conversion to int succeeded, and so we can jump forward. If it did not succeed, we can print error message like this. Output, we say bad input format, so input could not be converted to an integer. Output to this, we can then also print new line, right? So we can just print new line. This is fine, and then we can jump back. Right, this is anonymous jump back like this to have them retry. So we begin our retry right here at the beginning of our output. And with jumping forward, this is our final return, so we'll just say we're jumping forward. From here, we're jumping forward. This is anonymous jump forward to this location, and this is anonymous jump backward to this location. This is just the syntax of anonymous jumps. Now remember, A to D returns result, and if the result is successful conversion of this text entered by the user to integer, then there will be no overflow flag set. Otherwise the flag is set and we can report bad input format. Now let's also verify very quickly that there is no overflow in terms of the value. So we just want to make sure that the user entered something that is less than 255. Okay, so we can make this comparison. We can, for instance, one thing that we can do, we can test EAX against this mask. So we can enter 0, FF, 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 0, 0. And that's a hexadecimal mask. So test does something that AND operation does, right? So test basically applies this mask, and the outcome of this test will be that if, for example, this EAX input, right, so this is register EAX, so we are only interested in the lowest portion of it, which is register AL. And by testing this entire EAX input against this mask, which is like 1, 1, 1, 1, 1, all ones, so these are all hexadecimal F, all ones, except the last two, which is 0. So all of this is 0, 0, 0, 0. And now I can say that if it happens to be the value greater than 255, which is the biggest number, right? So if it's like 256 or some larger number, some of these bits will be set to non-zero bits. So by testing against these, I will be able to suppress all of these. They will be all zeros, right? So all over here, all results will be 0 because we're applying a zero mask right here to every bit. But here we're going to yield all ones. So if what's going to happen if the result of this test is such that it's not 0, so we can say jump if not 0. So the result of the test, and test basically what it does, it sets flags according to the result of bitwise AND operation. So if a jump, we can say a jump if 0, okay, we can jump forward. Just basically jump forward and add this anonymous label right here to jump to this label if the result is 0. So we can add a comment here. If basically if the entire value in EAX is less than 256, if you will. Okay, so that's the outcome of this test. We just apply this test. It's the same as testing whether the entire EAX fits into the lowest byte of the entire EAX. So if EAX less than 256, the input is acceptable, or let's say the input is valid. Okay, so we can say okay to continue. That's why we're jumping forward. However, if some of this mask values yielded any non-zero results, then we can report that this is a bad input format, try again, because we're specifically asking the user to enter 8-bit unsigned int. Okay, so we can just report this bad input format once again. Or we can even say arithmetic overflow. It doesn't matter. Let's do this. So we're just going to say output arithmetic overflow. So we can report this as an error. I'm just going to align my operands like this. Arithmetic overflow. We're going to print new line again at the end of this. Just print new line and unconditionally jump backward. Right, backward to actually no, not backward. We need to redo the input. So again, I'm going to say enter first enter first 8-bit, something like this. So we need to add this label right here, and we'll be jumping if we have this arithmetic overflow, because the number is not less than 256. We're going to have them re-enter. Okay, so this is our validation. Validate input range. Okay, input range. So we can validate it like this for our first 8-bit. So if this works, we can then try to continue with this, and now we have our first 8-bit input ready. Okay, so we have this, and so therefore we can just store it right here. How about we simply move the result to this location, and of course the result is in the lower part of register EAX, which is register AL. I'll keep this lowercase, by the way. Okay, so that's the idea. Let's see if we can proceed with this type of program so far. So let's do some testing with it. So I'm just going to build this code. Hopefully everything is okay, and we'll just run it. We can say F5, hit F5 to start in debugging mode. So we go to our first prompt. This output produces this line of characters, and we're now waiting for the input. So we're going to try something that looks bad, not very good input format. So now we're going to try something that looks big number. So this arithmetic overflow. So right here, our test detects that there is something outside of the range of 255, the biggest 8-bit signed number, right? So that is going to ask us to repeat, and so this time arithmetic overflow was printed right here, and so we're jumping back to the original prompt, enter first 8-bit unsigned int. So let's try something acceptable, 123, and this time everything works. We just fall through, we don't do anything, but I'm assuming that if the result is acceptable like this, this result will be contained in register AL, so we're actually storing it right here, right here in our memory, right, in the first 8-bit value.